What if you were asked to determine if a given function is a solution to a differential equation? The way you determine if a function is a solution to a differential equation is by simply verifying that when you plug the equation, it gives you an identity function. Now, for reference, an identity function can be something like x plus 3 equals x plus 3, or 0 equals 0. Those are identity functions. And similarly, what we have to do in this exercise is just take the function, for example, a, which was y of x equals x e to negative 3x, find its derivative to plug it into the differential equation up here, and just verify that we get an identity function. So let's see if this is a solution. So y prime x actually equal negative 3 e to negative 3x minus 3 e to negative 3x precise. And y prime of x equals negative 3 e to negative 3x plus 9 e to negative 3x plus minus 3 e to negative 3x. Okay, so now we solve this into the differential equation. So y prime is actually let me just substitute negative 6 e to negative 3x plus 9 e to negative 3x times x plus 6. Now y prime just e to negative 3x minus 3 e to negative 3x times x, and finally plus 9 y just x e to negative 3x. And they claim that this should equal 0. So this should all equal 0. Now let's verify. So negative 6 e to negative 3x plus 9 e to negative 3x times x plus 6 e to negative 3x minus 3 e to the negative 3x plus 9x e to negative 3x. Okay. So let's check. So we have negative 6 plus 6e, negative 3x, which cancel these, plus okay, so y prime, true root, opposite of this. Oh, sorry, 6 times 3 here is supposed to be 18 here. So this 18 actually cancels out because we have plus 9 and plus 9 and negative 18. So this just all goes to 0. So now we end up with 0 equal to 0. So this function x e to negative 3x is an identity, gives us an identity function when substituting. Therefore, it must be a solution to the differential equation y prime prime plus 6y prime plus 9y equals 0. Now, if we move on to, for example, b, and you just substitute 0 throughout the equation, you could easily tell that 0 plus 0 plus 0 equals 0. So b would be an obvious solution to this differential equation. Okay, so moving on to question 6, we're asked to find the slope of the function y of t, and we're asked to find the value, the initial t, when it equals negative 2, and finally the function y of t. So given that this is the graph y of t, it should have been specified because it could have been y prime, but this is actually the graph of y of t. You should try to solve this for yourself, but I'm going to show the solution right here. So initially, you could immediately find t naught because they say that y of t naught is equal to negative 2. But if you look at the graph, when you have negative 2, you're actually standing on t equals 0. So you could just determine that t naught must be equal to 0. Now, how do you find m? You actually need to perform the separation of variable. You're told that y prime of t equals mt, and you can rewrite this as dy over dt equals mt. What you want to do is have the dependent variable on one side and the independent variable on the other side. So we're going to do dy equals mt dt. And now we can integrate. This is going to give us y, and here the m is a constant, so you can have m integral t dt, which equals to mt squared over 2 plus c. Don't forget the plus c. And now that we have this, we could just grab points on the graph. So there was the point of y0 equals negative 2, and there's another point right here, like when t equals 2, that y is equal to 1. So 2 equal 1. And there you go. Now you have two variables in your equation because you have you know that y of t is equal to mt squared over 2 plus c. So you need to find c and m using these initial conditions. So I'm going to do that real quick. So there we go. We know that m is 3 over 2 and c equals -2. So now we could just write our general equation for the function, which is y equals 3 over 2 t squared over 2. So just we could just rewrite this as 3 over 4 t squared minus 2. And there we go. This is y of t. Okay, so moving on to question 7. This is also a relatively easy question because we're given the solution to some differential equation, and we just need to find the constant k and y naught. So if we know that y of t equals 3e to negative 4t, you can immediately find y naught because it's just telling you that y naught is the condition whenever t is equal to 0. So if you just plug in y equals 0, or t is equal to 0, you get 3e to negative 4 times 0, and this is just going to go to 1, so you just get 3. Very easy, right? And now k, to be able to find k, if y of t is a solution to this differential equation, then so is y prime of t, which is just going to be negative 12e to negative 4t. And now you just plug. So you go negative 12e to negative 4t plus k times 3e to negative 4t equals 0. Let's bring the 12 to the other side. We get 3k e to negative 4t is equal to 12e to negative 4t. Divide by e to negative 4t, this vanishes, and then divide by 3, and you'll get 4. K is equal to 4. There we go. Now we have k and we have y naught. Okay, so for the last question of this chapter, we're asked to take this differential equation and put it into the form of y prime plus p of t, y equals g of t. Now, the reason we're asked to put it in this form is because in chapter 2, this is actually a method to solve a first order differential equation, and the method is called separation of variable. But for now, we just need to practice putting it in this form. I'm probably going to upload a video in the future talking about separation of variable and other techniques. But for now, let's just focus on putting this in the form. So we're given 4ty plus e to the t y prime equals y divided by t squared plus 16. Now you should be aware that you need to always have the y prime at the beginning of the equation. So firstly, I'm just going to rewrite it like this. I'm going to bring this factor onto the other side because they have a y in common. So let me write it plus 4t y minus y over t squared plus 16 equals 0. Now, I'm going to factor out the y. So we have e to the t y prime plus y times 4t minus 1 over t squared plus 16 equals 0. We're going to divide everything by e to the t. So y prime plus y t minus 1 over t squared plus 16. And now all this times 1 over e to the t equals 0. So there we go. We have our equation in the form of the separation of variable, where this is our y times p of t, and this is our g of t right here. And for the last part of the question, we're asked to determine if it's linear, homogeneous, linear and non-homogeneous, or just non-linear. It is going to be linear because we have a constant coefficient, it's just 1 here. And for the coefficient of this y, we just have a function of t, which is fine. So you could have the independent variable in front of the dependent variable, and it'll still be linear. And for g of t is just 0, so this is going to be linear. And because g of t is 0, whenever your right-hand side of the equation is just equal to 0, you could say that it's homogeneous. So it's linear and homogeneous. And yeah, that'll be all for this question. Thanks for watching, guys. And for the next video I'm going to upload, it'll be based on chapter 2.